me and ask me question anytime. So tonight we're going to talk about data science. So this is kind of the introduction. Let me just switch okay, the introduction of data science. Uh, I guess I'm just going to skip this part. The thing that I like these days is there are many technologies. We call it emerging technologies, and some people said there are three new emerging technologies, eight new emerging technologies, and this one is 30 emerging technologies. But you can see that, basically there are many new things. One of them is artificial intelligence. We're going to talk about that later on, probably. We talked about Internet of Things. Mobile and social internet, we already knew since we are using it every day. Blockchain, maybe if we have the time, we'll talk about the blockchain. Now, this big data is the one that we are doing right now. Data science, and how do we handle this big data? How do we analyze them? Automation, robots, these are in plan. If you see immersive media and blockchain, usually people call it Web3. It's a combination of those two: mobile technology, cloud computing, 3D printing. 3D printing is interesting also, because right now I don't have 3D printer at home yet, but I have the normal printer. A long time ago, when I asked students, "Do you have printers?" And most of the students said, "No, I don't have printers." But printers these days are just common. Everybody have printers. So in the future, we're going to say the same thing with 3D printers. They're going to be common. At first, I was not convinced also the 3D printers, but we had guests, professors from MIT, and she talked about uh, 3D printers, and I believe that 3D printer is important. Customer journey, energy technology. These days people are talking about solar panel, batteries, and so on and so forth. So this is also new. Cybersecurity. This is my field. Voice assistants. Now everybody is going to talk about AI, but with voice instead of with just text. Nanotechnology, collaborative health, human computer, geospatial, and so on and so on and so on, and so on. Quantum computing. So basically, these are interesting technologies that we may have to face. Some of the technologies are what we call emerging. They emerge and create disruptions, and some of them probably just emerge and then it's just like a fad and they die. But if you see these days, AI is there and AI is creating many disruptions. And in the near future, we can see the same thing with quantum computing. So this is nice. This is what I like about my field is everything is new. Every day there's something new. Now, in terms of Indonesia, this is the thing about Indonesia. Indonesia, it's one of the biggest, probably number three or number four, the biggest place on earth. And if you can see, the total population is 285 millions, and the number of mobile phones 356 millions. It means that many Indonesians own more than two mobile phones. So this is common in Indonesia. The users, internet users, there are more than 200 millions. You can imagine then if you compare it with, say, Singapore. Singapore, the whole country is probably only 5, 6, 7 million. Malaysia, it's probably only 25 million. So you can imagine,
This meeting
for
is
us,
being
this is like
recorded.
a big thing for us, because everybody is using the internet these days in Indonesia. So this is a big market for everything. So that's why if you have any innovation in Indonesia, it's the best place to launch the innovation. If you create something new, for example, if you started in Singapore, probably it's too small. If you have something and you started in Indonesia, that's probably big. It's going to be, at least the market is there. And the adoption is quite interesting in Indonesia, and because everybody is using the internet in Indonesia. Okay. So I've talked about, in other places. I talked about the adoption in Indonesia. 80% technology is adopted in Indonesia. If you look outside, people are using mobile phones, right? In Indonesia, we have Gojek, Grab, what else? Uber. I think they're gone. Maxim, InDrive, and all kinds of new things. And then also we have all this e-commerce. We have Shopee, Tokopedia, and then what else?
Lazada,
Lazada, and then we have Grab Food,
Bukalapak. Hmm.
and so on, right? So many things, so many things. The thing that I miss when I'm abroad is actually Go Food or Grab Food. I can order it anytime I want, right? And even in I'm in even in a big say hotel, I can just order that. If I want to get something, I just go out to the lobby and then pick it up. That's the thing I'm missing. The same thing with payment. Only Indonesia, China, probably these two places are the one that innovations are happening these days. Okay, now that's why we are so excited in this field. I love statistics, so I look into my statistics, and one of the statistic that I use is Last FM. FM is a statistic about music. So when I play music, for example, I put an agent in my Google Chrome, my web
Web
browser, and my
browser and
music
my
applications, and you can see that these are the kind of the type of music that I'm listening to. And then this time where when I'm listening to the music, I think this one is from 3 years ago. Today is probably so. This is like this right now as FM. But you can see this is where I look for new artists. For example, I look into other people. Said, oh, okay, these people are discovering new music. So I just click on them and see what kind of music or artists they are listening to. So I discover a new artist through this mechanism. Okay. And this is actually the newer version of Last FM. They just make difference of the statistic. So these are the statistics. So you can see that these days I'm listening to what kind of music. So okay. Anyway, so every day we produce data every second. So this is a statistic that was produced maybe 5 years ago, and you can see that the trend is exponential. It's exponential. Uh, that's the data generated by human. But these days we also have data generated by machines from IoT, even my wristband and so on. So this is just kind of the situation right now. And if I look the recent statistic, and if you can see the trend is still going exponential. I don't know how big it is. I think it says, oh yeah, this is zettabytes. So you can see we have lots of data that we don't know how to deal with. Okay? And this is kind of a joke. And this is a person said, why is my LG washing machine using 3.6 gigabyte of data every day? So he was looking at the traffic. Why there's a big traffic in my house? So he was looking at the traffic, and he found out that the his washing machine, I don't know what it's doing. Maybe it's sending some kind of statistic, or maybe there's a malware inside this machine. I have no idea. But this is just the kind of things that we are going to deal in the near future. I actually already these days. So we have machines that are producing data and machines that are sending data to some site outside, and right now we are having a hard time understanding data generated by machines because they are too big. Even for us, and at least we can see the trend these days. Some of my friends, even my family, they do marathon this day. I don't because I pick a different kind of sport. But you can see that this is common. For every person, you can wear something. You can wear something in your head. You can strap it in your bicep. You can wear it just like most of us. We are wearing smartwatch, right? We walk to measure how many steps we walk, and so on. I know a friend of mine. He is a runner, so right now he's designing a shirt that can measure, that can sensor like his body, because he is running. Is about my age. We have to make sure that we are not crossing our limits, our boundaries. So when we run, we have to check our heart rate, oxygen, and so on. So what he is trying to do, he's trying to put all the sensor in the t-shirt. So when we put this t-shirt, not the t-shirt, but the shirt, and when you run, all you have to do is just monitor it in your cell phone, or somebody can follow you and monitor it in the cell phone and warn you if you are pushing too much, and say slow down and so on. And also there's sensors in the shoes. So right now, this is being developed for professional athletes, so they know whether they're doing fine, or they have problems in their kind of feet. If Football clubs around this day also using this method when they hire or they sign a new player. They ask the player to run, and then they monitor how the player runs. So these are just examples of what we're dealing these days. So that's why we call it the big data. There are five V's of big data. One is obviously this volume. We can see that there are many data. Some people call it the new oil. I don't call it the new oil. I'm calling data is the new junk, because we are producing junk every day, not oil junk. Although we can turn junk into money, but most of the data that we produce, there are basically junk. Okay, so the volume is just one thing. When we think about big data, it's not just about the volume, but the velocity, the speed of the data coming in. It's actually much faster than the our system or our body, our head, or even our machine can consume. Um, so the velocity is too fast for us to consume or to digest, to process the information. So the velocity is one, the other thing. Volume, velocity, and then variety. Variety means that the type of data is kind of nowadays a variety of data. Long time ago, we just have text data or numbers data, but these days we have text, numbers, images, videos, and all kind of forms of data. So basically, variety is the data itself. It's not just numbers or text data. Now, on top of that, we don't know the value of data. Like I said, this is mainly junk. We don't know the value of data, so we have to treat them accordingly. Say, for example, if we have data that's basically not important to us, then probably we're not going to store it in our database, because it's just too much to store all kind of data. So we have to check the value of the data, most important data. Then we're going to save only valuable data. So this is kind of a bit difficult also. And then the last one is the veracity, meaning that the uncertainty of data. So, for example, if a data says there are 235 banks in Indonesia, and then another data says there are 300 banks in Indonesia, which one is the correct one? So sometimes it is difficult for us to distinguish between data that is good and data that is bad, or that was created improperly. So anyway, this is just to point out that data right now is kind of wild and uncontrollable. So what we are dealing with, the big V, is just the kind of the aspect of big data these days. We have to deal with this. When we look into big data, usually when we look into places that are uncommon. For example, this is in sport. Formula One. Formula One is the place where everything is data. So, for example, this is a McLaren team, and they build race cars for each track based on historical data. And then they create simulation based on this, and then they're looking at, okay, if we are competing in this track in this kind of weather, what's the best setting or configuration for our car. Here's an example of what they have done in Mercedes. You can look it up this in In YouTube, there are many, 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 many videos. You can just search data science at Mercedes or McLaren, and they'll give you the list of videos. So during one kind of one event, say for example, if there's a weekend that they have competition, and they're collecting data. The data is obviously based on the machines itself, right? The drivers, the tires, what kind of tires that they're using. Is it a soft, hard compound? And then the number of laps that they have to go through, and then they're looking at the number of seconds if they have to go to pit stop. So this is kind of something that we need to deal with. And the thing is, when we think about it, the position of the car, the GPS location of the car, when we look into our phone, usually when we talk about our phone, the GPS is accurate, say 10 meters, 11 meters, or 15 meters, yeah. Because usually it says accurate 15 meters. But this one, the resolution is centimeter. You can imagine it's centimeter, like the car, the exact position. And then based on this, they can create a race strategy, and even they design the car based on this data. So this is kind of the competition between data, obviously data. They have PhDs there. So this is an example of Jenson Button's car, for example. And then you can also, this is Hamilton, Lewis Hamilton, and you can see how they drive, and you can see the differences, and so on and so forth. So this is kind of real deal, the real deal. Now, last week I already give you a homework, which I hope next week I'm going to check about the homework, whether you have watched it or not. So basically, we're going to talk about a book. The original was a book by Michael Lewis. Michael Lewis, uh, he's a very good writer. He has many, many, many books. The last book that I read was actually about going infinite. This is about FTX, one of those cryptocurrency exchange that went down very, very badly. And right now I'm reading the Premonition. So these are this book. Now, if you love movies, you can also see The Blind Side with Sandra Bullock, for example. So this is also a movie. It became a movie, and what we are interested in, Moneyball. So Moneyball. How many of you have watched it? Give me a thumbs. If you have not watched it, give thumb down. If you have not watched it, if you, let me see, where is my reaction? I don't have my reaction. Ha! If you have watched it, give me a thumbs up or indication. If you have not, give me thumbs down in the what do you call it, the reaction. No, I don't have my reaction for some reason. I don't have my reaction here. Okay, so only you have watched it. How about the rest of you? No, have not watched it, or so anyway. So this is a story about Oakland Athletics baseball team. uh so this is in the 2002 season. They were very, 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 very bad, and they were at the very bottom of the league. I think not the last one, but I think one above the last team in the roster. So they didn't have the money, and they need to trade the players, and they need to buy new players. The manager at the time, the GM at that time, Billy Beans, was asked to rebuild the team. And one day he went and he went to an office, and then he stumbled with this guy, Peter Brand. And Peter Brand, basically, he is a nerd. He loves statistics. He loves numbers. He loves computer. So they built together a team based on numbers. So they based on numbers. Okay. And what they're doing is they're using a matrix. They call it Saber metric. Okay, so this is the Saber metric, is the matrix that they're using to build the team. Okay, so that's kind of interesting. Hang on a second, let me just record this one. Uh, so this is what, well, now because of what they are doing, they could build. I don't want to spoil the video, but the other movies, but basically they were able to create history because they're just using statistics. So that's that. That's an example of data science in sports. Okay, so now let's turn into science in cartoons. So we talk about this. Simon Singh wrote a book, also a book. They said The Simpsons and Their Mathematical Secrets. And basically, I just realized that in this cartoons series, there are many mathematics inside or behind the scene. So this book, I'm reading this book. I think I'm almost done reading this book. I'm not finished it yet, but almost done reading this book. So in The Simpsons and Futurama. So The Simpsons itself, it's a popular cartoon by I forgot the Mark Groening. So inside this Simpson, this is a family of Homer Simpson, the father, Marge the mother, and their three kids. The first one is Lisa, and then the famous one is Bart Simpson, and then the smallest one is Maggie. So they have many stories. Now in season 22, so you can imagine that there are more than 20 seasons. Episode 3, and the title was Money Bart. So I remember the film is Moneyball, and this episode is Money Bart because of Bart Simpson. So in this episode, Lisa Simpson wanted to go to an Ivy League university. So she wanted to go to this Ivy League university, and there are alumni or maybe students from this Ivy League university came to the school. And then Lisa asked them how to get admitted into this university. And they said, you have to have extracurricular activities. What do you mean by extracurricular? Anything. So Lisa decided to become the coach of Bart Simpson's baseball team. So she's doing what exactly Peter Brand was doing. If you look at into this book, there are many jokes about this. Say, for example, F equal ma, Newton, right? This one is Euler, statistic, and then one of the kind of the buku saktinya di dalam buku sakti, like the thing in sports baseball is this Bill James, and this is Moneyball, that book. And then you also have Schrodinger's bat instead of Schrodinger's cat. So this is Schrodinger's bat, and so on and so on. So basically, if you look into this, there are many mathematical jokes. And if you look into the movie itself, right? The Futurama, the same thing. Apparently, in the writers, there are many mathematical experts. Very cool mathematical experts. We call it mathematical professors, basically. So in cartoon, there are also many data science kind of. And same thing in football or soccer. This is a Liverpool football club. And you can see in this example, for example, player number 24. So this player number 24 can pass the ball to say number 22, to slide it to number 28 or number 18. So you can have simulation what's going to happen if he passes the ball to number 17, to number 25, or slide in to number 26. So that's the kind of simulation that they have. This was from, I think, 3 years ago lah, the statistic. So right now they're also still dominating the Premier League, and not just Liverpool. Other groups are also doing the same thing. In fact, I've just watched I think a series, a Korean drama, same thing. It's about a volleyball, same thing. Okay. Anyway, Data science in agriculture coming up. We are going. This is basically from my experience. We are doing many experimentation these days using IoT in aqua and agriculture. So this is actually a snapshot that I took a few minutes ago from our sensors. We are developing many sensors these days. For example, this is the Maros, south of Sulawesi. Sarang, Krisan Sarang is in the back of our house. Cibaduyut, Cipangeran, Cimahi Utara, Kopo, PAOMA, it's at ITB. So we are developing sensor. I'm only showing this two metrics, temperature and humidity, but we also have other kind of other data for other physical data, temperature, humidity, solar radiation, ultraviolet, pressure, uh, and so on. I think it's about seven or nine kind of data. Okay. So we hope that we can make a decision based on data. For example, COVID 3 years ago, we have to put restriction where people have to stay at home or they are allowed to be allowed outside. Now, when you want to put a handbrake kind of when should we start and when should we stop? What is the consideration? Should we consider based on health metrics only or economics or so on? Okay. So if you look into this aspect, say for example from a health point of view, how many beds are available? Originally we only look at the number of patients, but at the end we say, oh, okay, so that's actually a good measure, a good number. But we should also look at the number of beds in hospital, the availability of beds, and then look at the economy factor also, the trend, and then the social, whether many people are going to psychiatrists or to doctors, because if you are confined in small room in your houses or even your apartments, there is stress. So this is why we are putting sensors in and every places. In fact, this is kind of a scary thing because we are putting sensors in all kinds of stuff, including our body. Now, again, I love books, so I'm reading so many books. And this book is from Professor Zuboff, Professor Susanna Zuboff. She said that these days we are entering an economy based on surveillance. So what we are looking at, the economy is based on surveillance that is controlled by a selected number of companies, namely Google, Facebook, and probably Microsoft, Apple, and so on. But these two companies are dominating our lives, Google and Facebook. If you open an application this day, you actually log in into something that requires Google account, for example. Now, she said that in the old days when we provide data, we are expecting something in return for our benefits. Okay, if you ask my data, what do I get in return? Okay, free services. Okay, give me free services. I'll provide you with my phone number. Okay, something like that. Okay, but these days, the data are collected by companies and they're using this data not for our benefit, but for their own benefit. For example, they're selling this data to advertising companies, which may or may not be benefited for us. For example, they know, okay, I love coffee, then they're going to put ads. Okay, this is new coffee shop around you. This is coffee, new coffee, and so on. But what they're doing right now is they're doing that beyond that. They're forcing us to go to places that we don't want to go. Subconsciously, they said, "Oh, okay, there's a new coffee shop there." So basically, they're forcing us to, or at least they're forcing me to go to that place because my the way I'm wired, right? So this is a concern for privacy. Um, what if the data that they're collected, or if the data about myself is incorrect there? For example, the age is incorrect, maybe the disease is incorrect. So for example, what if they miscorrect me or mislabel me as a person who is bankrupt, so I cannot I cannot create credit cards, for example. I cannot get a credit card or loan from a bank because they think that I am bankrupt. So I don't know the type of data that they're collecting about me, whether the data is correct. So this kind of put a pressure on the society, and the kind of the final nail was this. Okay, this is a great movie, also documentary. The Great Hack is a documentary. I think a long time ago. It is in Netflix. I don't know whether it's still in Netflix. So this story was about Facebook when they had problems with Cambridge Analytica. So the story, like the simple version of this, to make the story short, uh, when I don't know how many of you have Facebook accounts. How many of you have Facebook account? No, raise hand if you have Facebook accounts, or say yes. I don't know how many of you have Facebook account. Only of one. How about the rest of you? How many of you have Facebook accounts? No. Tell me. Let me just stop first. Okay. Oh, okay. If I stop, apparently, I have to stop this to see. Okay. Okay. Two, three. Okay. Now, when you have a Facebook account a long time ago, there are games in Facebook account, right? For example, there is a questionnaire. If you are an animal, what kind of animal are you? So they have questions and we answer them. Okay, you are a dog, for example, right? Or if you are a superhero, what kind of superhero are you? There are questions, and then they said, oh yeah, you are Spider-Man or whatever, right? So when we ask this, when we played with this game, usually at first they say it, okay, before we play this game, we need to have access to your profile. Um, Give us access to your profile, and we say yes. That's that. For us, it's okay, right? Because we trust this application. Okay. Now the problem was at that time of Facebook configuration was something kind of wrong, so that companies who are running this application or games, they can look at our friends also. So instead of just looking at me, they can also look at into our friends profile, kind of. So what they're doing is they're profiling all the users. They're profiling me, and they're also profiling my friends. That was a problem. And the data that they compiled, they send it to companies, and they send it also to countries. I think it was Indonesia was also mentioned in that. So if you want to win an election, you can hire one of these companies, and they will provide you. Oh, okay. If you want to win, you go to smaller mosque in that area, small this, go make dakwah in that area, and you get elected by this person. In this region, different things you provide them with dangdutan, for example, right? And in this region, you provide us with sembako or whatever. So they have that kind of data, um, which is interesting and scary at the same time. Because of this, because of this, uh, sorry, the European basically legalized GDPR, sorry, GDPR, which is the Indonesian equivalence of Undang-Undang PDP, Perlindungan Data Pribadi, which is we have right now. But before that, we didn't have, right? It was PDP 2 years ago, I think it was announced. Anyway, uh, Professor Zubob said, if there is no business model, there is no incentive for these companies to change their business model, because their business model is just that: collect our data and then sell it to other companies. So that's that. Okay. Anyway, now before we go into the definition of data science, is there a question or clarification?
Pak,
Yes.
I have a question, Pak.
Yeah. Go ahead.
I think that you mentioned in film Simpson, like Moneyball and Moneyball, regarding cybermetric that you mentioned.
Uh,
It seems like a combination technology such as predictive analysis,
mm.
big data processing, machine learning, and optimization, sir, that complement each other, that are right, sir? Or
For today, yes, but if you think about it, in the old days, people were not talking about machine learning, right? Those days, when many of these people, or the people earlier who created, say, sabermetrics in the sport, they're not using machine learning. They're basically using statistics. In this class, we'll do that one also. Yeah. So, but these days, you are right. These days is a combination of many things, as later we'll see. Ada lagi pertanyaan? Follow up?
Once again, sir,
Yep.
regarding the privacy, sir.
Yep.
I think when we go to website, sometimes we can get notification to
Hmm.
accept regarding cookies.
Hmm.
I think what is the safe from the my data privacy or not, sir?
Okay. Technology wise, so here's the thing. Technology wise, web was not designed to do multiple transaction. The protocol itself will designed to one time. So if I go to website, we say, give me this data, and the website will say, this is your data. That's it. Now the problem with that is that the website cannot identify me. So who is that person? The way system tracks is to put something in my web browser to identify. So the first thing, I go to a website, they said, "Oh, you are new here. Let me add something to you so I can identify you, how you are, and I can serve you better." That's what they said. If I can serve you better. So, for example, if you click on web or pages that have coffee, oh, probably you like coffee, and I can save you, I can serve you better. The other thing, if I have a login page, I identify myself. This is Budi. Oh, okay. Next time I will identify you as Budi. To do that, basically they need to put something in my web browser. That's what we call cookies. It's basically a long string, a long number, and they put long number, kind of a random number. They put in my web browser, or our web browser. So the next time I go to their site, and it's like, oh, okay, I have this cookie, and then said, oh yeah, okay, you are Budi, okay. Go through and do your thing. You can buy stuff because I already know that you are Budi, and that this I have your data, and then that's fine. Now, so that's the reason that they are doing that. Now the other thing is, additionally, now this is what we call optional. They want to serve me better, for example, by looking at, okay, what computers or handphones or tablets are you using? That it's not necessary actually. So that's what we call optional. Say they said I want to serve you better, but I have to know your computer. Is it Windows or Macintosh or whatever? In my opinion, that's not necessary. So he said no. So that's why in the option sometimes you say the functional, that's necessary. That you have to say yes. The other one, for preference, there's also usually for performance and things like that. For basically for their processes, we say no. So when there is an option, when you open website and it says, okay, now we need to do something, do not accept all. Go to the preference, and usually they say, okay, preference, and only click that is functionally necessary. The others you set off, 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 and then save my preference. Okay, so that's
Okay, thank you, Pak.
okay. Ad- ada lagi sebelum other question before we move on to the next slide. Okay. Anyway, if you have any question, feel free to stop me. Okay. Now let's go to the theory. What is data science? Now there are many definition of data science, but this is the one that I like. The Venn diagram by Drew Conway. Let's get my tablet first so I can write this and I can create. Wait. Okay. Let me just see if I can write something on my screen. Okay. Yeah. Okay. Now, so when we say about data science, what is data science? And Drew Conway was one of the first person to draw this definition, and I like this definition. And his definition is not formal. Okay. So the first one is what we call a substantive expertise. Or we can also say domain knowledge. This is the domain knowledge. For example, if you are in e-commerce, then you are selling clothing, for example. So you are in these areas, the substantive expertise. If you are say in manufacturing, this is a kind of knowledge of manufacturing. If you are in education, you are in education. If you are in entertainment, and so this is basically what you are. So I'm positioning you in this position now. After this, if you want say if you want to open another store, you own a restaurant, if you are a franchise and you want to open your second or third restaurant, what do I do? So what do you do? Usually you have a traditional research. You ask somebody to do a survey or a polling. Now that's what we are looking. Usually we ask somebody who knows statistics. Okay. Okay, can you create statistic basically to find out where should we put our store and so on. So this is what we call a traditional research, a combination intersection between your domain knowledge and the math or statistic knowledge. So this is the combination of domain knowledge and statistic. This is traditionally that what we do. Okay. So if we have also now, if we have the math, statistic, and Drew Conway call it hacking skill. So this is hacking skill. Is this is basically in the formal term, this is computer science or computer engineering, computer science kind of. Okay. Uh, Basically, it says if you have a combination of computer science and mathematical skill or statistic skill, this is what we call a machine learning. We'll have a session on AI later on, maybe next week or 2 weeks from now, to see what machine learning or AI is. Okay, so this is a combination of that one. Uh, the reason why one of the reasons why Drew Conway say hacking skill is just because sometimes you need person who is expert in computers. They're not necessarily graduates for computer science school, probably somebody who knows computing, programming, and so on. So this is basically programming. Okay. Now, if we only have the domain knowledge, know nothing about statistic, and we just talk directly to a computer programmer, so this is what we call danger zone, because we know nothing about math, and we just asking our programmers to do it, or we are the programmers to do all the coding without necessarily know math and statistics. This is kind of very dangerous. I'll explain that one later on. Now, in this particular diagram, we can see that data science is a combination of these three fields: the domain knowledge, the expertise of whatever fields that you are interested in or you are knowledgeable in, and then math and statistics, and computer programming. So these three skills, this is what we call data science. And in my opinion, this is actually a team. So it's not a one person doing these three things, but a team which consists of three, at least three person who knows the domain, math and statistic, and computer some kind of. So this is a team, in my opinion. This is more reasonable to have a team. In this particular class, what I'm trying to do is I'm trying to wait. And I'm just going to clean this one first. Erase all. I'm going to clean. Sorry, I'm going to clean screen, and then I'm going to put you in this expert this side. So I'm going to teach you a bit about math and statistic, but I'm not going to turn you into a math and statistic expert. The same thing, we're going to do some kind of programming. We're going to use Python programming. I'm not trying to turn you into a programmer, but I'm going to show you what programming looks like and how it feels. The same thing with math. We're going to use math, and we're going to do linear regression, clustering, simple math, just to get kind of get the hang of the feeling of these three fields. Okay, so you are going to be here, but I'm going to teach you a bit of this and a bit of this. So I'm going to teach you a bit of this. Okay. Now this is kind of informal, but if you look for a formal one, this is a more formal one. Somebody turned it into a more formal definition. So this is the domain expert, math and statistic. This one computer science or IT. Okay, but I like this one better because this is it gives this one gives you like in your face kind of description. Okay, now now let me go back to this, right? Now, the trend these days is basically people are trying to get you to do all the coding with a system that requires no coding or very small or low coding. So these days there is a trend. Sorry, there is a trend. Wait. There is a trend to let's see. Okay, there is a trend to introduce coding tools in this region. Okay. At the same time, now, if you think about it, wait. Okay. Now, with AI, now we can move towards this. So we take the burden of the mathematical statistics into a machine and let the machine figure out the mathematical behind the complexity of the problems. This is good and bad at the same time. The good thing is we don't have to know anything about math or statistic. The bad stuff is if we don't know if something breaks down, we don't know how to process it. Okay. So let me go back to this the danger zone. What do you mean by danger zone, Pak Budi? Okay. So, for example, we are the expert here. We know nothing about this math and statistic. We know nothing about this, and we just hire somebody who's doing IT or coding. Okay, so there's kind of a joke about this. Let me just okay. This is the data science show. This is from Gilbert. So Gilbert, this is Gilbert, and he is the IT kind of the nerd guy, and this is his boss. And the boss says, use the CRS database to size the market. So he wants to find out the size of the market. And Gilbert said, sir, that data is wrong. And then the boss said, okay, then use the SIBS or SIBS database instead of that one. And Gilbert said, well, that data is also wrong. And then the boss said, can you average them? And then Gilbert says jokingly, sure, I can multiply them also if you want. So in bahasa Indonesia something like this. Kata orang ini ada orang bisnis dan orang IT. Orang bisnis bilang, carikan data pendapatan penduduk Kota Bandung data dari BPS. Kata orang IT-nya, Pak, data BPS tidak akurat. Kalau gitu gunakan data dari pajak aja. Datanya juga tidak akurat. Kalau begitu kita rata-ratakan saja itu. Bisa Pak, mau saya kalikan juga bisa, mau diakarkan juga bisa, mau dipangkatkan juga bisa Pak. Jadi kalau orang IT itu ya semuanya bisa. IT said, you can do anything with the data, but if the formula is wrong, there's nothing, right? So this is what we call danger zone because you know nothing about, you know nothing about math. Okay, so be careful. This is just warning. Be careful, yeah. So you have to know a bit about math. Ada pertanyaan before I move on? Okay. Yeah. So this is the data science that we are going to use. So we're going to. I'm assuming you already have something in your hand. You are knowledgeable in this area. So I'm going to teach you a bit about this and a bit about this. Maybe 2 weeks from now. Okay. So let's start with the tools that we are going to use. We're not going to install anything on our computer, but just to be sure that there are many tools out there. First of all, the format of the data itself, it could be anything. So the data could be in text format, in column format, for example, in your spreadsheet format and your Excel format. It could be comma separated value in CSV format. And if you are programming this day, it's in JSON format or XML format or free format. For example, if you're getting data from Twitter, for example, or Facebook. Okay, so these are the data that we have. Based on in this data, there are many tools to do some kind of what we call data wrangling or data manipulation, which basically turn in one format of data into another format, and so on. So this is just a way to process the data. So we can capture the data and put it inside the computer and do whatever we want. The type of data also varies. In the old days, it's just numbers and text, but these days we also have images, audio, video, and in generic terms they call it blobs. Any binary format that we don't know, call it blobs. So these are the types of data that we need to deal with. Okay, so based on this, we need to find tools to get an idea, or some kind of visualization to get an idea what the data looks like, the distribution of data, so we can write program or maybe delete attributes that we don't need to make it simpler, because it's too complicated. So there are many tools that, and then we're going to see not all but some of them. Now, in terms of the phase, what we're going to do is probably only this part. So we take the snapshot of the data. We only describe what the data is. So the data we want to get insight. For example, the distribution of the data, the structure of the data. That's it probably in this class because we don't have like much time. After this, the next thing to do once we have the kind of the description of our data, we want to diagnose if there is something wrong, or if we are looking at the trends, if there is something anomaly that we don't know. Again, this is we're trying to diagnose our company's system or what have you. Based on this, we can say, oh, okay, we know the data, we know the quality, we know the direction, so we can predict the future. Okay, we can do what if scenarios, what if this, what if that, what if this, and also predict if we invest in two or more stores, what benefit can we gain, uh, what is the return on investment, for example. So this is kind of the predict the future. If we have problems, it will also we should be able to find the root cause, and it will kind of describe and prescribe what we can do. Maybe next week we'll talk more about AI, the agentic AI. So the original of AI was to describe and diagnose in only these two part. But now our AI these days can actually also give us a direction or prediction. But we'll see. We'll say why we are doing that, and why are we still sticking with a human to do the decision making. Okay. So what we are doing is on the left side. We are going to use some kind of math or statistic to find a model that we want. So this is using statistics or math to find a model. Okay. So we put back diagram. This is a science way of doing it, an engineering of doing it, the common way of doing it. This is the old ways of doing it. Now, in the newer way of doing it, machine learning or AI, we are using examples. We don't know the math. We don't know the statistic. We don't know the formula behind it, but we know the answer. So, for example, this is good, this is bad, this is from our manufacturing. This is a good product. It looks like this. This is the bad product. It looks like this. So basically, trying to figure out the model based on examples. So it's kind of this is different, right? The big differences between data science and machine learning. And in data science, we are still looking for experts. Remember the Venn diagram, the math and statistic. We're still looking for experts to help us to find the proper model, kind of the statistic or the model behind it. But in machine learning, we're trying to reduce as much as possible human interaction. If we can take away the human equation from it, that's better. So this is kind of the approach of AI. For example, in this math, We are learning, oh, okay, let's do that, and let's find, say, linear regression, for example. Linear regression. Okay. And this one in this section, we don't need to do that. We want to find examples, which basically the AI will find this linear regression, but we don't need to understand the function kind of good and bad. Okay, we'll discuss about this next week. And then the tools also say, so these are examples of the tools that we have these days. In the old days, it was very, very difficult. The tools were scattered and expensive. But these days, we can have many, many tools, and some of them are free. For example, we have data. So, example, we have data. And first of all, we have to store them. This is what they call, used to be called database, right? So we have database. In the old days, database was very, very limited. SQL database or very expensive, difficult to tame, very restricted in the numbers of data it can save or it can process. But these days, we have all kinds of database. The popular one, for example, MySQL or MySQL, and then Postgres, even MongoDB, and so on and so forth. Obviously, there's also still Oracle DB2, Sybase, Microsoft SQL Server, and so on and so forth. So those are also DBMS. But in this example, we can see that there are many many alternatives, and these are open source or free alternatives. So that's just one the data source. We're not going to look into this. We're going to assume that it's already given. We're not going to manage our database, but we have already data. Now, based on the data, we can stuff our data. We can stuff data and put it inside this. And then we may want to transform the data. Remember, we have to transfer data and make it easier for us to process. So there are tools to do that. For example, we have Spark. We have all kinds of SQL language to put it into this. And we have Python programming language to transform this into something that it's easier for us to process. Once we have our data, we want to get something to create a model. Now, there are many, many tools, modules, library to do that. I think in this class, we're going to use Pandas, Matplotlib, maybe some kind of scikit learn to transform this data and to create model. Uh, Once we have model, sometimes or many times we want to see how it looks like, because most of us we kind of we tend to get more hunch or more idea if we can see the data. So there are many ways to see or visualize the data. These are tools. There's GNU-plot, there's D3, there's Matplotlib. These are basically visualization. And then on top of this, when we want to have our system um, like a large scale, big scales, then we might want to have some kind of queuing system to make our system scalable. We want to have some kind of cache and in-memory processing. We have Redis, and these are tools to make it scalable. Okay, if we want to make it bigger. So these are example of tools that are available out there. We're not going to use all of these tools. I'm just going to give you a snippet of what this tool can do. Just give you an idea of how to process them. Okay. So there's many tools. Now, these are tools that kind of are very low level, not low level, but very, very rudimentary. But there are many tools that are specific for data science. For example, you have Nime, Orange, and Snowflake. I guess it's Snowflake here. There are places that they have collected all the data and tools. There are many, 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 many tools. So that's that. Now, in terms of the data processing itself, it used to be very difficult, and you have to learn all kinds of languages. For example, when you use statistic long time ago, you have to use S, the language. Now these days, you can use R, for example. No, but see, if you want to do statistic, you have to use R. For visual, you have to use this another language. For this, you have to learn another language. So it's kind of difficult. That's why These days Python is the Swiss Army language. So that's why I'm going to teach you. I'm going to teach you how to program in Python. So you can use Python to do all kinds of things, statistics, processing applications, AI, and many things. Okay, so we're going to use Python. Okay, and if you see many courses outside, there are many courses that says data scientist with Python. So everything is Python. Don't worry if you don't know Python yet. We're going to teach you Python. Okay. Now the statistics side, I'm going to there are many things. Probably, uh, hmm, probably only these two. Okay. Okay. Nearest neighbor in the class. Don't worry about that. I'm just going to skip this. Okay. Okay. Now case studies, there are many case studies. I'm going to talk maybe only simple case studies, but there are visualization of COVID, detection and mail of spam. This is what we are doing now. Weather. There are many cases doing sentiment analysis, brand image, political tendencies. We have not done many hospital data. Actually, we've done quite a bit only in hospital data. Right now, my main focus in IoT data and weather, climate change, and so on. Okay. Visualization with COVID. This is an example. A while ago, I was part of Jawa Barat group that analyzes COVID. So, for example, um, when we have COVID, where should we, what is the decision of the governor or the head of the city, say mayor of the city, should we do this or that? So that's what we want to do. Basically, I wrote a program that pulls data from many places and then it plots the data. Let me see if I can play this one. Let's see, can can I play this one? So this is an example. I wrote the music also. Anyway, so that's that. Okay. So in the end, my point is that data science, it is actually a team, not individual. I'm not trying to turn you into a Superman, but I'm going to teach you how to do some kind of programming and a bit of statistics, so you know what data science is. You get the feeling of data science is, so you can build your own team to solve your problem. So that's that. What I'm going to talk tonight. Questions? Silahkan kalau ada pertanyaan, questions.
Pak,
Yes.
uh, as you explaining and mention about the data science in danger zones
Hmm.
and in data science, Pak, in
Hmm.
real life nowadays, how we get accurate data and believing the data is credible?
Hmm. Sorry, what was the question again?
In real life nowadays, how
Hmm.
we get the accurate data and believing that data is credible?
So yeah, as the saying goes, garbage in, garbage out, right? So we have to find out what is the best data, because we want to get the best data or the real data and to fit in our data into our system. What is the best way, or how do we guarantee that the data is good? Now, the first thing is to find the source. So you have to identify the source first. Um, it has to be credible from the source. The source. If you feed your system with bad data, then unfortunately it's going to give you garbage. Now, the problem is that sometimes the source is limited, or you know that the source, the credible source, it's not accessible. For example, if you want to have a data patient, for example, you cannot just ask a hospital to give you data, because there have regulation, privacy, and so on and so forth. So sometimes the number of data is limited. Now, the second best thing is you scour the community of data science or even the internet for collection of data. Uh, the best bet is to look into data that is gathered for scientific purposes. So you go into papers to check what kind of data that they're using, so we can use the same data to predict or to analyze our system. After that, now sometimes we cannot access the real data from the main source. Sometimes the paper has certain data, scientific community has data, but it's not enough. Now the third one, you have to get your data yourself. That's the hardest part because it's going to take a long time and it's going to be expensive. The third one, and then the fourth one, you generate kind of data based on your intuition, kind of best guess. So that's that. Now, these days, the first one sometimes difficult. The second way is through academic communities. The second one is this day is rapidly growing. You have communities that collect data together, pull data together, collect data to do research, even for commercial purposes. So there are the data system that stores examples that we can use, we can borrow to create our own model, kind of. But still, you have to go through the sources, that in that order.
Yes. Gitu.
Ada lagi siapa yang mau bertanya? Let me just, yes,
Sir,
Yudi.
yeah. I want to ask about the use, the implementation of the data science, yeah, sir.
Hmm.
Because I have learned maybe not many as you learn, yeah. I have learned a little bit, yeah, about the Python, ya kan, and
Hmm.
Orange, yeah,
Hmm.
SQL, yeah. But I still confused about the use the use of the data itself, yeah,
Hmm.
to make the implementation is
Hmm.
easier, yeah. Sorry, so that the data
Hmm.
will be used for make a decision, sorry,
Hmm.
how to use the data to get uh, more accurate decision. Yeah,
Hmm.
as maybe in a point of view of for a decision maker, sorry.
Yeah.
Uh,
So I give you an example. For example, right now we are interested or more focusing in climate change and sustainability development. So what we are trying to do is to get data from environment, climate, and to find out the effect on business process. Our main interest these days is in aquaculture business, um, tambak ikan, apa namanya apa sih namanya bahan nori nori itu apa namanya let me just stop this one